Astronomers have just discovered a mysterious new world, lurking in the far reaches of our solar system well beyond the orbit of Pluto. Named 2017 OF201, this icy object is now one of the most distant bodies ever detected. Its orbit is enormous, stretching more than 1,600 times farther from the Sun than Earth, and it takes a staggering 25,000 years to complete just one trip around the Sun. This discovery excites scientists not just because of how far away it is, but because of what it might disprove. For years, astronomers have searched for an unseen giant planet, called Planet 9, that they believe shapes the orbits of distant objects. However, 2017 OF201 doesn't behave as the Planet 9 theory predicted. Its orbit is oddly different compared to other distant objects, suggesting that what scientists once thought was evidence for Planet 9 might simply be coincidence. Finding something so small and distant required incredible patience and technology. 2017 OF201 is so far away that it appears as nothing more than a tiny dot of light in even the most powerful telescopes. Astronomers had to analyze images taken over several years to confirm its existence. They tracked its slow movement against the background of stars, proving it was indeed a real object orbiting our Sun. To understand what 2017 OF201 actually is, we need to know about dwarf planets. Unlike the 8 major planets, dwarf planets are smaller worlds that orbit the Sun but don't have enough gravity to clear other objects from their paths. Pluto is the most famous example, having been reclassified from a planet to a dwarf planet in 2006. Currently, scientists officially recognize 5 dwarf planets: Ceres, Pluto, Haumea, Makemake, and Eris. Ceres lives in the asteroid belt between Mars and Jupiter, while the others orbit beyond Neptune in a region called the Kuiper Belt, based on its estimated size of about 700 kilometers across. 2017 OF201 could potentially join this exclusive group. The region beyond Neptune contains thousands of icy objects, collectively called trans-Neptunian objects or TNOs. Most are small, irregularly shaped chunks of ice and rock. However, some grow large enough to form spheres under their own gravity, a key requirement for dwarf planet status. Scientists believe hundreds more dwarf planets may exist in these outer regions, waiting to be discovered. What makes 2017 OF201 truly special is how far it travels from the Sun. At its most distant point, it ventures 1,600 times farther from the Sun than Earth does, deep into a mysterious region called the inner Oort cloud. This vast, cold territory marks the very edge of our solar system, where the Sun's gravitational influence barely reaches. The discovery of 2017 OF201 provides valuable clues about how our solar system formed and evolved. Each new object found in these distant regions helps scientists piece together the complex history of our cosmic neighborhood. The unusual orbit of this object suggests it experienced powerful gravitational interactions in the past, perhaps with Neptune, or even with passing stars. For astronomers, finding 2017 OF201 feels like discovering a time capsule, because it spends most of its time in the cold, dark outer reaches of the solar system. Its surface likely contains materials that have remained largely unchanged since the solar system's birth, over 4.5 billion years ago. These ancient ices could hold secrets about the conditions that existed when Earth and the other planets were just beginning to form. As telescopes peer deeper into the darkness surrounding our solar system, what other mysterious worlds might be hiding there? And what might they reveal about the true nature of Planet 9? Or something even more unexpected lurking in the shadows beyond Neptune? Finding an object like 2017 OF201 requires both advanced technology and clever scientific methods. Unlike planets such as Jupiter or Saturn that can be seen with simple telescopes, this distant world is incredibly faint. Even with powerful modern telescopes, it appears as nothing more than a tiny speck of light. The team that discovered 2017 OF201 used a special approach. Rather than taking new images, they searched through archives of photos taken by large observatories over many years. They developed computer programs that could automatically scan thousands of images, looking for objects that moved very slowly against the background of fixed stars. This slow movement is the telltale sign of a distant solar system object. After identifying potential candidates, astronomers confirmed 2017 OF201 by tracking it across multiple images taken between 2011 and 2018. By connecting these observations, they could calculate its orbit with remarkable precision. The discovery was officially announced in 2025 through the Minor Planet Center, which tracks and catalogs objects in our solar system. Scientists estimate that 2017 OF201 is approximately 700 kilometers in diameter, about one-fifth the size of our moon. This measurement comes from analyzing how bright the object appears from Earth. Since they can't see it directly, astronomers use its brightness and estimated reflectivity to calculate its size. At this size, 2017 OF201 is large enough that its own gravity has likely pulled it into a spherical shape. One of the key requirements for dwarf planet status, the surface of 2017 OF201 appears reddish when viewed through special filters. This red color is common among distant icy objects and reveals important information about its composition. Scientists believe the reddish hue comes from complex carbon-rich molecules that form when simple ices like methane and water are exposed to cosmic radiation. For billions of years, these molecules, called tholins, create a dark, reddish crust on the object's surface. What truly makes 2017 OF201 remarkable is its extraordinary orbit. Most planets follow nearly circular paths around the Sun, but 2017 OF201's orbit is extremely elongated, almost like a stretched-out oval. At its closest approach to the Sun, it comes within about 45 astronomical units, similar to Pluto's distance, but at its farthest point, it travels an incredible 1,600 astronomical units from the Sun, more than 40 times farther than Pluto ever ventures. This extreme orbit means 2017 OF201 takes approximately 25,000 years to complete just one trip around the Sun. For comparison, Earth takes only 365 days, while Pluto needs 248 years. During most of its journey, 2017 OF201 moves through the coldest, darkest regions of our solar system, where temperatures drop to nearly absolute zero, to 73 C. The unusual path of 2017 OF201 raises important questions about its origin. Most objects in our solar system formed from the same spinning disk of gas and dust that created the Sun and planets. But 2017 OF201's orbit suggests it experienced powerful gravitational interactions that dramatically altered its path. Some scientists propose it may have been thrown outward by a close encounter with Neptune early in the solar system's history. Others suggest it might have been influenced by the gravity of passing stars when our Sun was younger. Measuring the properties of such a distant object pushes the limits of current technology. As scientists continue to study 2017 OF201, they've noticed something strange about its movement, subtle irregularities that can't be explained by the gravity of the known planets. Could these unexplained motions be evidence of something else lurking in the darkness beyond Neptune? The discovery of 2017 OF201 has profound implications for our understanding of the solar system. This distant world challenges existing theories and opens new questions about what exists in the vast space beyond Neptune. Scientists now must reconsider some of their most fundamental ideas about our cosmic neighborhood. For years, astronomers have proposed the existence of Planet 9, a massive, undiscovered planet thought to be shaping the orbits of distant objects. This theory emerged because several known trans-Neptunian objects show similar orbital patterns, as if influenced by a single large body. However, 2017 OF201 does not follow this pattern. Its orbit differs significantly from what Planet 9 would predict, suggesting the clustering of other objects might be coincidental rather than caused by an unseen planet. This doesn't necessarily mean Planet 9 doesn't exist. Rather, it indicates the outer solar system is more complex than previously thought. Some scientists now propose alternative explanations for the observed orbital patterns. Perhaps the combined gravitational effects of many smaller objects create the same patterns, once attributed to Planet 9. Others suggest temporary influences from passing stars might have shaped these orbits billions of years ago. The region where 2017 OF201 travels represents one of the last unexplored frontiers in our solar system. This vast area between the Kuiper Belt and the distant Oort cloud was once thought to be relatively empty. Now, with each new discovery like 2017 OF201, scientists realize this region likely contains numerous large icy worlds following their own unique paths around the Sun. These objects are particularly valuable to science because they preserve materials from the early solar system. Unlike planets closer to the Sun, which have experienced significant heating and geological activity, distant worlds like 2017 OF201 remain largely unchanged since their formation. They contain ices and organic compounds that provide clues about the conditions that existed when planets were forming 4.5 billion years ago. Finding more objects like 2017 of 201 will require new technologies and approaches. The upcoming Vera C. Rubin Observatory, scheduled to begin operations soon, will conduct the most comprehensive survey of the night sky ever attempted. Its massive 8.4-meter mirror and 200-megapixel camera will capture images of the entire visible sky every few nights, potentially revealing hundreds of new distant objects. Space agencies are also considering missions to explore the outer solar system more directly, while sending spacecraft to objects as distant as 2017 of 201 remains challenging with current technology. Closer trans-Neptunian objects could be reached in the coming decades. NASA's New Horizons mission, which flew past Pluto in 2015, and the Kuiper Belt object Arrokoth in 2019, demonstrated the scientific value of visiting these distant worlds. The study of objects like 2017 OF201 connects to broader questions about planetary systems throughout the galaxy. As astronomers discover more solar systems around other stars, they find many have different structures than our own. Understanding the full extent and composition of our solar system helps scientists place it in context among the diverse planetary systems observed elsewhere in the Milky Way. For the general public, discoveries like 2017 of 201 remind us how much remains unknown even in our cosmic backyard. Despite centuries of astronomical observations, major components of our solar system continue to be discovered. Each finding expands our perspective and challenges our understanding of our place in the universe. As telescopes continue scanning the skies and new data pours in, astronomers have noticed something peculiar about several recently discovered distant objects, including 2017 of 201. Their orbits show subtle disturbances that cannot be explained by known forces. Could these be signs of interaction with an entirely different class of objects? Perhaps remnants from another star system that passed through our own billions of years ago?